Have 256 QAM, as I had already explained earlier. These are some features with which we can increase the throughput. We had in LT up to downlink 64 QAM, and then in advanced LT advanced and LT advanced pro, we already had downlink 256 QAM, and here as well in 5G we are going to use the downlink 256 QAM right from the beginning. Okay, so there will be no 64 QAM. I mean, when I say there will be no 64 QAM, if the condition is bad, if the UE is in poor conditions, obviously the throughput will decrease and the modulation will reduce to 64. But 5G will get introduced with 256 QAM as the baseline. Then we have beamforming antennas. So initially we used to have a conventional array of antennas like how you see in the picture here. And then there used to be interference. That's where we had ICIC, enhanced interchannel interference, and then those will be sorted out here because we will have a different antenna arrays for each antenna. So if you see here, the main beam will be beam forming, and the advantage of this will be, since the array of the antenna is like this, it's in oval, it will take care of the far UEs. For example, if the whole cell is like this, and if this is the cell center, then normally what happens is the UEs in the cell edge, they do not get good throughput. Okay, hardly they get like QPSK or even BPSK, and then they don't even stay connected and you lose the signal, right? That will not happen in case of 5G because of these beamforming array antennas. And then these multiple layers, as we talked about, up to 64 layers on over the air. In the lab testing, we normally stick to 4x4 or 8x8. Some customers also have patch panels configured, and then they can go up to 16x16. But again, I mean, it's better if we do multiple layers on over the air. That's when you get the best benefit out of 5G. Okay, and we have up to 8 CA. So CA is nothing but carrier aggregation. You guys might have already heard about carrier aggregation in LTE. So it's basically nothing like you have one component carrier, let's say cell A, which is the primary anchor. And then if you want to increase the throughput on cell A, you add another component carrier, let's assume cell B, but that will be added as a secondary cell, which will be called S cell, primary cell and secondary cell. But the secondary cell will only be for the downlink. That is downlink carrier aggregation. Okay. We also have uplink carrier aggregation, but there was no requirement in terms of LTE for uplink carrier aggregation. There was more for downlink because most of them wants to only download and see the data, right? Uploading happens at a fairly lesser speed and pace as compared to downloading. So uplink CA is available, but it will be there from 5G onwards. But in 4G, we had 2 carrier aggregation, 3 CA, right? In advanced LT advanced and LT advanced pro. Now in 5G, we have up to 8 carrier aggregations. So the difference between carrier aggregation in 4G and 5G will be when we aggregate 2 carriers in LTE. So if you remember LTE, the maximum throughput bandwidth in the cell was 20 megahertz was the max. Okay. So when you combine 20 megahertz together, so probably you can get 300 Mbps and 300 Mbps, 600 Mbps would be the max throughput that you can get. Okay. But now with FR1, we have about 400 megahertz. And FR1, we have 100 megahertz, which has 273 PRBs, and FR2, we have 400 megahertz. Okay. So 400 megahertz, if you combine carrier aggregation, that's going to be a lot of throughput. Because FR1 alone with 100 megahertz, we are already testing about 1.8 Gbps. Okay. That's where we pointed out saying, if you go back to the first slide, we mentioned that in 5G, we are looking at greater than 10 Gbps. In FR1, a single cell can do up to 1.8 Gbps. And in FR2, a single cell can do up to 7.5 Gbps, right? So when we are looking at greater than 10 Gbps, we then have to do a carrier aggregation and probably some more of these features to be brought into picture. Okay. By the way, in the lab, we are already testing 8 carrier aggregation, and we are getting about 7 Gbps through. All right. So these are the various things which will enable us to reach our goal for 5G. Okay. Now, apart from this, if you see, there are multiple other things which are happening. For example, virtualization in 5G core. So 5G core, I mean, previously we had EPC, right? And EPC was more like MME and HSS. The components were different. And now in 5G core, we have AMF, session management, UPF, taking care of the data plane. And all these are virtualized as well. Previously, it used to be like, I mean, they used to be in a container, they used to be in a server. Now they are all containers, and we talk about Docker system in India. Apart from that, there is also an open RAN concept. Open RAN, vRAN is cloud RAN is nothing but we used to say E node B in LTE and G node B in 5G. Now the G node B used to be a single monolithic block, right? Now that is divided with Open RAN. What they do is they are divided into RU, DU, and CU, right? Radio unit, distributed unit, and the centralized unit. So since these are divided, we can bring in more companies and more. For example, there are a lot of companies in Bangalore who are making only the DUs, okay, and there are some companies who are making only the CU. So you can interop all of these together and do an IoT, right? Interoperability. When I say IoT here, it is interoperability testing, and it gives more. Otherwise, there used to be only few companies like Nokia, Ericsson, Samsung, Huawei, ZTE, who used to be the E node B manufacturers, right? Now we bring in totally different, another whole set of customers like Mavner, Altiostar, Radisys. All these are players in DU, CU, right? So that's where this 5G has brought in more opportunities. And the last point is dynamic spectrum sharing, which is very important in India because, for example, if you already have LTE cell which is deployed, right? For example, it's a 20 megahertz cell, and then caters to, it has a lot of capacity, but then in the wherever the LTE cell is deployed, if the capacity is not that much, for example, it can handle up to 100 users, but we have only 30 users, and the average is maybe around 20-25 users at any given point of time. And even at peak times, which is very rare, which we call BHC, busy hour times or something, even then the capacity touches only 50 or 60. Then in that case, we can reuse the remaining part of that for 5G. Okay, that is something called dynamic spectrum sharing. That is a lot of companies in India, when they deploy 5G, they will be looking at DSS, dynamic spectrum sharing. Let me move to the other slide. Okay, so these are basically the use cases which I have been mentioning since beginning. So 5G is not just about the mobile technology. It is going to be smart city. So when you say smart city, for example, if you want to monitor your the electricity, right? I mean, you don't want, previously we used to have it as a manual effort. Now we don't want it. Automatically it has to be, similarly the traffic lights. So we don't want any manual interception for traffic lights or for anything. So water meter, reading of water meters or electricity meters, or even the gas readings, all these can be done with NB-IoT. So NB-IoT is nothing but narrowband IoT. And IoT here, I mean as Internet of Things. And narrowband actually started a little like LTE Advanced or LTE Pro, but it will be put to use best with 5G coming into picture, especially when we have ultra reliable low latency. That is where, so that's what sensing, metering, monitoring, right? All these will be the use cases for 5G. And then we talk about connected vehicles, the cars, ambulances, which is very important, right? If anything happens, the ambulances should immediately receive a notification of the coordinates, and then they should reach there. And once we have the patient, the accident victim or whoever it is, once we have it in there, we need to ensure that some kind of remote surgery has to happen, and then the basic things which are like blood pressure and all those things are automatically taken, right? So that's where this URLLC will be of utmost important in healthcare, because most of the things can be made automated, and we can also rely on the regular monitoring of the readings. Okay. I've already talked about IoT, then more number of devices, higher throughput. Okay, these are the use cases that will be for. So this is just a pictorial representation. For example, here the speed is increasing, the signal quality gets better, and then we introduce big data, and you can also introduce AI, right? If you introduce AI and machine learning, and then all these incorporated with this, then because 5G is going to have a lot of data, when you talk about monitoring periodically or sensing anything periodically, it's going to give you loads and loads of data. So we need to have some big data analysis to post process the logs as well. So this is how it will be, the lifestyle, the whole our surroundings and everything will be changed based on how we see things, right? So starting from speed, signal, the big data, internet, latency basically. And then if you see here, mobile applications uploading and downloading to the cloud, right? And then this is the internet speed. And then this is the coverage, the antenna directions. Here comes your IoT, where you connect your laptop, not just laptop, I mean, whatever the home appliances we have, for example, the refrigerator, the washing machine, with IPv6 coming into picture, we can have all these have an IP, and we can have a smart homes or smart city. And then with an application on your phone, you can turn on, turn off, or do whatever. You can monitor basically those devices. They will always be on the network. Yeah, this is also a security challenge. So security plays a major role here as well, like network security, right? For example, if there is a car going, whether there is an attack on the devices or sensors, and then if you want to identify, authenticate, authorize, we all know that LTE had a lot of authentication and security algorithms. The same works for 5G as well, right? And then you can have a pre-collected data generated by devices in the network. And then here is where your big data will come into picture in order to see what kind of data has been collected and what all has to be segregated, what are information to us, and what are probably redundant data or something like that. So on the health system, probably most of these are self-explanatory slides, but I mean, these are very important slides. These are the exact challenges that will be, coming in. So one more thing I would want to point out is the 5G auction in India has not happened yet. I'm sure all the operators are waiting for that to happen. Probably end of this year or early next year is when the 5G auction is planning to happen. And I think most of you guys would have listened to our Mr. Mukesh Ambani's AGM annual general meeting, where he mentioned that somewhere around middle of next year is when we will have the 5G deployed in India, right? By the way, to give you an update, there is already testing going on in all the operators and NEMs uh, in India, and they are already testing their networks. It's just not deployed because we don't have the spectrum yet, but it is in the lab. We are in cabled environment. It's already being tested, and it's just a matter of rollout to happen. So once the auctions are done and once the documents and everything, the approvals are in place, I don't think it will take a long time for India to deploy 5G, considering that we have the need and we have, we have a lot of density, right? We have dense cities like Mumbai, Delhi, Bangalore, Chennai, and Pune. So Hyderabad. I'm sure with all these applications coming into picture, we will have a lot of requirement. And then let's quickly talk about the career path here. So as you know, telecom based companies, we have operators, mostly in India. It is Airtel, Jio, and then VI, Vodafone India. And NEMs are nothing but equipment manufacturers. Like I told you, the tier one equipment manufacturers were Nokia, Ericsson, Samsung, Huawei, ZTE, right? Those used to make their own E Node Bs or G Node Bs. Now with Open RAN coming into picture, we have DU and CU. We have different stacks, right? For example, Radis is a company which makes their own stack. Radis is now acquired by Jio as well. And then we have Mavner, we have Altiostar, And then we have Airspan, which comes up with their own RU. RU is a radio unit, right? I mean, there is tons of opportunities in 4G, and like I told you, I mean, I started my career with 4G back in 2009, right? And almost a decade I worked in LTE. I worked in RAN part. I moved to the core part, then on the gateway, co-located gateway, and again I came back to the RAN part, and now since last November, December, I've been working on 5G on both SA and NSA, right? And then we have these enterprise businesses as well. Enterprise business is nothing like these Dell, Google, Oracle. For example, TCS also has a team which is working on the telecom, right? So basically, they provide services to the other product-based companies. So these are the list of all the product-based companies, the NEMs that are available, right? And then these are the carriers across the globe. So I mean, the 5G is here to stay. I mean, I would say that at least for another, if not a decade, I would say at least 5 6 years, because the technology keeps changing quite fast, right? And then considering that the technology keeps changing, we need to adopt and upgrade ourselves and change our skill set, and we need to learn, keep learning here. So learning never stops. And these are the companies. We have at least like 20 companies in India who are already working on 5G, right? And just imagine, once if the auction happens and then once it gets deployed, there will be tons of issues seen as well, because RF is always, it will always work fine in the lab, right? But when you deploy it over the air, that's when like it opens a can of worms. So there is a lot of scope in 4G and 5G. 4G is, I would say, almost it's already stable, right? I mean, we don't have anything new to be. It will probably stay as a primary anchor. But with 5G coming in, and since it is not just in the mobile world, it's going to create a big havoc in the digitization.